Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today we're going to be talking about a problem, an integration problem involving substitution. And all we really have to do is do the substitution and clean it up a little bit and show it off. So if you have any questions about this problem, please feel free to put them in the comments below. And if you have any other problems that you'd like to see done, please put them down there as well. So let's get into this one. This one asks you to perform the substitution u equals sine of x on the following integral, expressing it entirely as an integral in u. You might need to use the identity sine squared plus cosine squared equals 1 to change from one representation to another. You do not need to evaluate the resulting integral. So we've got our integral from 0 to pi over 2 of cosine cubed times sine cubed dx. So we have this. We've got two different things here we're going to be working with. So we've got our u, which is sine of x. And then we're given the Pythagorean identity in terms of sines and cosines. So sine squared of x plus cosine squared of x equals 1. And then we have our integral. So the integral is going to go from 0 to pi over 2 of cosine of x cubed times the sine of x cubed dx. Now we can replace this sine of x right here with u, and that'll be worthwhile. And we've also got this dx here that we've got to work with. So we get the dx from integrating our u, and I'm going to assume that you've seen this before. So you take the derivative of the u equals sine of x, and you get du is equal to the derivative of sine, which is cosine of x, times dx. And that's where our dx is going to come from. So let's go ahead and do that substitution first, and then we'll see what we've got left over. So we've got the integral from 0 to pi over 2 of cosine of x cubed times, and instead of sine of x, I'm going to put in u. So you've got u cubed. And then instead of dx, I'm going to put du over cosine of x. Because if you solve du equals cosine of x dx, and you solve that for dx, dx is going to be equal to du over cosine of x. So what does that give us? So a little bit of simplification. So we get to cancel out one cosine with a cosine here, and we end up with 0 to pi over 2 of cosine of x squared times u cubed du. Okay, so now how do we get rid of that cosine of x? I can't use the u because that's in terms of sine of x, and the du, if I use that, it would make things really, really weird. That's where the trig function comes in, because that gives us a relationship between sine squared and cosine squared. And if I knew what cosine squared was in terms of sine squared, well, I know sine is u, sine of x is u, and so I'd get a substitution, and I can turn cosine squared of x into something involving u, which is what I want. So taking that Pythagorean identity and solving it for cosine, I get cosine squared of x, or solve it for cosine squared of x. I get cosine squared of x equals 1 minus sine squared of x. And so now I can plug that in. I can replace that cosine of x squared, or cosine squared of x, with 1 minus sine squared of x, u cubed du. And now I can replace sine squared with u squared. So we're going to go from 0 to pi over 2 times 1 minus u squared times u cubed. Now I can go ahead and distribute that u cubed. And there's one other thing that I want to do. I want to change the limits of integration from x values to u values. So I was told that u is equal to the sine of x. So when x is equal to 0, well, what's the sine of 0? That's just 0. So that means u is equal to 0. And if x is equal to pi over 2, well, looking at your unit circle, you see that sine of pi over 2 is equal to 1. So now I can write my integral entirely in terms of u. I go now from 0 to 1 of my integral, which is going to be u cubed, so I'm going to distribute that u cubed, minus u to the 5th du. And that's it. We don't have to evaluate it. We're all done there. And so thanks for watching, and I'll see you for the next problem.